Hello, I'm Misha Safrinka, and I would like to introduce how we here at NASA use TaskForce and MoveIt for Robonaut mobility. For those that aren't familiar, Robonaut 2 is a humanoid robot designed for purposes of for autonomous logistics for intravehicular activities. And what this essentially means is our tool needs to be able to handle a broad range of different tasks in microgravity environments, such as handling cargo transfer bags, moving around the module using the handrails, looking at specific points, and even dexterously handling different types of objects. One of the examples we worked on was, for example, turning a valve. Right? R2 is an extremely complex system, and I'm definitely not going to go over all of the challenges this system presents. For the scope of this presentation, I would like to talk about two specific challenges and how Robonaut solves them. Motion planning and the complexity of the system itself. Robonaut 2 is a fairly large robot that needs to operate inside a relatively cramped environment and must also be able to solve high-dimensional motion planning problems, as well as find and execute constrained motion plans. For example, on the right, you can see Robonaut in Argos, which simulates microgravity, but constrains the torso movement of Robonaut, its roll and pitch, which means that we have to, if we want to translate between the rails, we have to abide by those constraints. Robots in general are complex systems, and Robonaut is even more so. Its activities are supported by a lot of different processes, some of which are safety critical, and we must be able to work with them. As a research platform, it also requires a fast testing and implementation cycles. And since Robonaut is expected to perform all of its functions on ISS, tight control over its operation is a must. To solve these problems, we employ two major tools. TaskForce, which helps us create a centralized interface as well as quickly develop and test new capabilities, and essentially serves as the connective tissue of the entire system. And MoveIt, which we use for motion planning. Using MoveIt as a base, we have our custom tree kinematic samplers, as well as custom constrained motion planners that helps us deal with the types of motion planning problems we face. Unfortunately, MoveIt doesn't solve. MoveIt comes with its own set of problems that adds to the complexity problem of the entire system. Interaction with MoveIt isn't as instantaneous as we would like. For example, adding collision meshes to the planning scene, changing the motion planning parameters, and requesting a different type of motion plans do not have a very direct interface which would allow us to control the robots to the degree that we want. There is also only so much you can do with the GUI. For example, trying to go between the rails with the GUI is extremely difficult and not very friendly if you want to do this for multiple rails and generate multiple motions. There are more esoteric things that are very specific to R2. For example, running multiple instances of the robot model, which would allow us to severely reduce some of the computational difficulties for some of our algorithms, and so on. Luckily, TaskForce solves these problems for us as well. TaskForce as a platform was developed for rapid prototyping, leveraging a component-based programming model. Its IDE allows for encapsulating activities into discrete tasks and linking them together for larger functionalities. It also allows to run runtime development and inspection of running tasks. In TaskForce, the most basic elements are tasks, which are written in Python and have both asynchronous and synchronous paradigms, which means we can control these tasks in multiple ways. These tasks can be grouped together into groups, essentially, and nested, and groups can be nested in each other. Each task can also be parameterized with arbitrary set of parameters that can be easily changed during runtime. You also have access to login window displaying the logged information of the task being executed, so you can track the processes that how the processes are being run. All of these features of TaskForce can be leveraged to solve the problems we talked about. For example, TaskForce allows us to create different types of centralized interface and allows a greater degree of operator control. These two examples show that the interfaces can also vary. We can either have a very loose collection of tasks that perform a variety of different functions, or in the same players that could be easily modified and executed. For example, setting different controller parameters, loading different camera settings, driving robot to specific numerical joint configurations, and more are easily accessible at any moment at runtime. You also have the option of introducing group logic that connects the tasks together in an execution pattern that allows for sequencing tasks. Of course, you aren't limited to these two patterns, and the larger group arrangement of tasks and this interface is completely up to the developer. The bottom example just shows how, for example, what kind of tasks I need to be executed in order to motion plan between a very specific set of handrails for us to move around. The tasks themselves can be parameterized with key value pairs that can be changed at any point. This creates three valuable characteristics that help us maintain a high degree of control over our system. Taking this motion planning task as an example, you can see pretty extensive set of parameters. This allows the specific task to be reused for different move groups to different goals using different planners. This also adds in the transparency of what's actually going on with the tasks. Since we're able to view the set parameters directly, we can be certain under what kind of settings the task actually operates. Finally, the parameter of the task can be changed during runtime, allowing the user to quickly respond to unexpected events, and the difference between to unexpected events and the difference between reality and robot perception of it. Which really helps in the demos. Setting parameters is effective for our purposes, but this isn't the limit of TaskForce. We can use other tasks to set parameters as well. In a more simple example, on the bottom left, this allows passing the information between tasks sequentially. And for a more complex example, this allows us to have a centralized manager with its own internal logic. Using this feature, we can create effective connective tissue between different parts of our system, where instead of just controlling what a single task does, we can control a variety of tasks which are individually developed and tested. In this example, we can see that a state manager has actually control over different parts of the robot system. Scanning the environment, which is the vision system, opening the gripper where we talk directly to the controllers. We also talking to MoveIt as we plan, as well as the planning scene where we change the collision handler and so on. Which means that we not only be able to execute tasks by them sequentially or in some kind of arbitrary order, we're also able to pass information between them, which is very valuable if you're building a complex system. Lastly, TaskForce also allows for fast-paced development of the tasks themselves and the system as a whole. In this example, we can see that some kind of a problem with the task, we can immediately explode. We can immediately explode this programs quickly by just double-clicking on task and looking what's going on inside. We can identify the problem, obviously, and make a very quick implementation of the solution, right? The system is technically still running, so we just redeploy this specific group. We start it up again, and the execution is successful. Since tasks are essentially atomized action, your system can be discretized in a manner that will allow for development of individual actions, replacing the old ones as you iterate through the entire system and continuously improving your entire pipeline. So how does this all come together? For example, we find a plan For example, we find a plan with the necessary constraints. To the goalpost, and we expand, but except this plan collides with the wall. So what do we need to do? So we can execute it. We need to replan with additional collision measures. Usually this would be a lengthy process, but luckily for us, we can just use one of the already implemented tasks to insert the collision inside of our planning scene, which can be reflected here. While inserting the scene with the collision into the planning scene, we also inserted the collision for the handler, which means that our robot is currently in a state of collision and we won't be able to plan. In order for us to continue, we have to change the allowed collision matrix. We have a task for this as well, except this task changes a collision with the octomap instead of a specific mesh. Since we know the name of the mesh, we just change this specific parameter. We set it to a specific, we set the parameters for this task, and we start it up. Our collision matrix is already changed. Now we can start replanning. Since this probably configuration won't be useful to find a new plan that considers the collision model, our task automatically figures out which configuration would be useful and tries to find a plan to them. And as you can see in a couple of seconds, it finds a plan that both satisfied all of the constraints and also satisfies the collision with the environment. Even though the motion might not be as desirable as we would like it first. But we can obviously replan and find alternative plans. So this was pretty dense example, and I would like to kind of go over what you actually would need to do in order to execute it if you didn't have TaskForce. You would essentially have to create a mesh message. You would have to populate it. You would have to figure out the specific pose you need to mesh to be in. You would have to get the planning scene, ablate the planning scene, and request a service code to ablate the planning scene, right? And this is not something that can be done in terminal specifically. It's a pretty hard to do, and it would be hard to change parameters for something like this, right? Especially if you just run in a very specific node, and you're not even, and for new users, they might not even know if this kind of node might exist in your system. For the second step, updating collision matrix is something that, at least I find for a complex system like Robonaut, is not very doable inside of the terminal. Just knowing the specific values of the different parts of this of the allowed collision matrix and keep them in your mind is just not something that any developer wants. But luckily, you can develop a specific task that does this in a clever way, which accomplishes everything that you need. And lastly, we go to the motion planning problem where we construct a motion planning service for a number of different configurations, which allows us to test different motion plans quickly and replan only once instead of asking it for multiple times, right? And eventually we find a plan and we manage to get the desired motion that we want, right? So in conclusion, TaskForce and MoveIt are two incredibly useful tools that build on top of each other, right? We can use MoveIt to find complex motion plans and move the robot around with the desired constraints and motions that we need, but we also use TaskForce to control MoveIt much more effectively. This allows the development process of different types of motions and for different types of scenarios to be a lot faster than you would initially expect. We also can connect other systems with each other and send information between them, which creates a much more holistic view of the entire system for you as a developer. And you spend much less time dedicating to developing a specific task, since all of them are parameterized, since all of them are pretty much changeable extremely quickly, and since all of them by design are supposed to be atomized in order for your entire pipeline to be efficient. Where TaskForce is NASA internal for now, We are currently working on both releasing TaskForce and Robonaut 2 simulation to the public, which means that you will be able soon to access all of these resources and hopefully use it for your own projects. Any questions? I guess not, since this is pre-recorded. Thank you.